I am Professor C.S.P. Rao, working as a Professor of Mechanical Engineering at the National Institute of Technology, Warangal. The very subject of computer integrated manufacturing on which the lecture series is being developed. I had about 18 years of experience in this particular area, and I have been writing books and articles in this very much area. As a part of this lecture series, today let us discuss about the importance of material storage and material handling and storage in computer integrated manufacturing scenario. We have already discussed the various aspects of automated guided vehicles, asynchronous transfer mode of material handling in a SIM environment. We discussed the types of AGVs, the classifications, etc. in the previous classes. Today I am going to discuss about the storage capacity and how to storage, automatic storage of the in-process inventory or finished goods or raw materials, and the retrieval of the raw materials, because in a conventional manufacturing system we did not take stock of inventory management, whether that is WIP, work in process inventory, or finished goods inventory or raw material inventory. We did not have an account of it, whereas in computer integrated manufacturing system we need to have an account of the WIP or finished goods, anything. Certain operations will be done at certain workstation, and after that the work parts need to be stored and they need to be retrieved as and when it is wanted. All these things can be done with the help of automatic storage and retrieval system. The ASRS, popularly known, which is omnipresent in all SIM environments. The contents of the lecture as follows: overview of ASRS, problems of conventional storage systems, about ASRS systems, types of ASRS systems, and application examples and conclusions. The overview of automatic storage and retrieval systems. ASRS refers to a variety of computer controlled method of automatically depositing and retrieving loads from defined storage locations. ASRS are used widely in both manufacturing and distribution operations to hold and buffer the flow of material moving through the process to the ultimate end user. You can see in automated warehouses, ASR is a well-known system. There are certain problems associated with the conventional storage systems. Much time spent for searching because we cannot remember the exact location where the material was deposited. Thus, we normally use searching process to identify the material, and it is all a skillful operation based upon the person who is going to locate that. And lost or damaged products and inaccurate records. We cannot have the records of storage of the goods, and in this process certain goods cannot be retrieved in time, and timely retrieval of the goods losses indicates the loss of the good, and sometimes the age of the goods is also expires. Orders spending too much time in the factory, causing customer deliveries to be late. Wastage of lot of space. Nowadays the space is very essential commodity, and we need to optimally use the space, and in a conventional storage the wastage of space is one of the parameters. Excess inventory management, we don't have any control over the inventory management. Surplus inventories or will indicate the inventory holding costs and thereby recurring losses. And workers are exposed to dangers. All these reasons invented the need and development of automatic storage and retrieval systems. Why ASRS, or the need of the ASRS? Space efficiency, because height to cube ratios perfectly very well within the control. No need to allocate space so human can remember location and find. Every location is tabulated, every location is With the help of computer, the location and the barcoded item, which location the item is stored, is already recorded and available in the computer. At the click of the button or the mouse, we can easily retrieve the records of the stored items. Improved inventory management, accuracy of the counts, what kind of component, how many number of components exist, date of manufacturing, date of storage, everything will be available on the records. If any item is, its shelf life is decreasing, you will get an indication about the shelf life of each component. Knowledge of locations, aging and security, better data is available with all these things, and thus we have an improved inventory management. Quick storage and retrievals, where the location, what locations are vacant at the present, will be able to know about it, and thus we can easily store in which location you want, and you can retrieve as and when you want. Eliminate manual operations, because we use all agiles and all automated cranes systems for the automatic deposition of the workpieces or the components or the products. Thus we do not use human beings. Human beings need not lift to greater heights to store the material. Handling devices are available which will take care of the handling of the work parts in the system itself. Concepts of ASRS. You can see in this figure a typical ASRS, a vertically lot of bins are there, and it is a structured, steel structured. The operation is completely automated. The computer controlled and fully integrated with the factory and warehouse operations. The system is completely integrated with the warehouse or the computer integrated manufacturing system operations. The concept of ASRS arrived due to the space efficiency, utility savings, knowledge of location, safety, zone storage, distribution, and multiple locations of items, breakdowns of the systems, and response time, less breakage, pilferage, etc. You can see in this slide the basic structure of an ASRS, automated storage and retrieval systems. It has several stackers. They are all stacks, and the space in between the stacks is called as aisle. And here is a stacker crane, SR machine, storage and retrieval machine. This is called as stacker or storage or retrieval machine, which will travel in this aisle and try to locate to it. Can move horizontally as well as it can move vertically, and it reach any space available in the space racks. It can reach to any storage racks. If it is number of rows and number of columns if are known to us, easily ith row, jth column is the storage location of a storage rack. So the SR machine can be diverted, can be asked to move to that particular storage rack to get the component retrieved or to store the component holding. And we have a storage space. The storage space is designed depending upon the maximum storage of the item in the manufacturing unit. Depending upon, we can design the space of the storage rack. Here we can have any number of units like this. You can, depending upon the storage capacity that we want, and this total height is called as rack height, and this is the rack width and our rack depth. So the depth indicates that how much length of the component or how many components, total number of how many baskets that in which the components are placed can be kept in each storage rack. And this is the total rack length, and this is the total width of the ASRS. Width of the ASRS can be increased depending upon the space that is available on the shop floor. It can be increased, and number of aisles and number of stacker racks can be constructed like this. Basic structure of the ASRS is storage structure only it is, and we have a storage and retrieval machine, SR machine, which is normally a crane, and storage modules or pallets for unit loads. The loads are kept in pallets and the pallets are kept in the storage bins. One or more pickups and deposition station we can have where the component will be picked up, and also stored items will be retrieved and then placed. So pickup points, pickup and deposition stations. You can have more than one pickup and deposition station depending upon the number of requests that we get about the retrieval or storage components. You can have number of servicing SR machines. At each SR machine we need to have one pickup and deposition station, and you can have any number of SR machines depending upon your number of ISILs and other things. This is always being linked to the external manufacturing system. And the basic structure of the ASRS, you can see that the storage, this is the entire storage structure. It is normally a steel structure and divided clearly with division of base, number of base, and each is a storage module. And depending upon the kind of product that we are going to store, we can design this, whether it can be in a transparent one or a closed kind of box. We can design this as well. And we have this the SR machine, which will storage and retrieval machine. It will have a stacker crane, and the crane is operated longitudinally, vertically, in a storage module. The components that we have already discussed are the storage space. It is the three-dimensional space in the storage rack used to store a single load of material. Storage racks, this structure of the structural entity comprises storage locations, bays and rows. Bay, it is the height of the storage rack from floor to the ceiling. Row, it is a series of bays placed side by side. ISIL, it is spacing between two rows for the machine operations of ASRS. ISIL unit, it encompasses ISIL space racks adjacent to an ISIL. Components, the storage structure, which is the rack framework made of fabricated steel, supports the load contained in the ASRS. An SR machine, storage and retrieval machine, is used to accomplish storage transaction, delivering loads from the input station into the storage and retrieving loads or goods from the storage to retrieving station. So in this, you can see these diagrams indicate they are all self-explanatory about the SR machine. Storage modules are the unit load containers of the stored material, include pallets, steel wire baskets and containers, plastic tote pans, etc. Pickup and deposit station is where loads are transferred into and out of the ASRS, generally located at the ASIL for access the external handling system that brings loads to the ASRS and takes loads away. The components of ASRS, the external handling system brings loads to the ASRS and takes loads away. You can take it as an AGV or RGV or RTV. AGV, automated guided vehicle, rail guided vehicle, or robot transfer vehicle. There are several kinds of external handling systems which the ASRS has been integrated. Basic structures of ASRS. You can see in this diagram the structure of an ASRS. Which is automatically operated, can reduce waste storage of place, protect the product. The product security is very good in this. Applications. ASR associated with warehouses and distributed operation systems. Applications of ASRS: unit load storage and handling, order picking and work in process storage system, etc. ASRS for WIP, ASRS for work in process inventory. Buffer storage in production. Buffer is nothing but the semi-finished goods available between the two workstations. When one workstation processes the part, and after completion of the processing, it waits for the second workstation to get processed. Meanwhile, it has to wait. It has to wait for sometimes for the inspection purpose also. In these cases, this waiting for the next operation, a semi-finished good waiting for the next operation, it is called as in-process inventory, work in process inventory. This WIP is a raw material on which certain operations are performed, and it is waiting for certain operations to be done on that. And such kind of WIP, when the waiting time is in days, then it has to send back to the warehouse or retrieval or storage or retrieval system, and it will be picked up as and when it is required. Otherwise, the entire space between the two machines gets filled up with the WIP, and there is no space for work. So ASRS will take care of this kind of thing. Support of just-in-time deliveries. It will take care of that, and it delivers as and when it is required. Kitting of parts for assembly. It will deliver the parts for the assembly. Compatible with automatic identification systems. And computer controls and tracking of material. It will track the materials. By any chance, any material is there, how many kinds of such WIP goods are available in the storage, you will have a record of it. So you can easily plan how many more components to be machined, how much the inventory is there, and how much more inventory you can plan, and to how many days this inventory can be served, WIP can be used for further operations. All these things can be meticulously planned. Support of factory wide automation. Types of automatic storage and retrieval systems, which include unit load ASRS, mini load ASRS, deep lane ASRS, man on board ASRS, automated item retrieval systems. Depending upon the applications, we can have one of these types can be designed and kept in our factory. Unit load ASRS. The unit load ASRS is used to store and retrieve loads that are palletized and stored in standard sized containers. The system is computer controlled. The loads are generally over 500 lb pounds per unit. Heavier loads cannot be used in unit load carriers. Unit load ASRS. This figure typically shows a practical ASRS, unit load ASRS. You see some components like this. They're all placed. Only one component is kept in one bay. One component is kept in one storage location. You can have it. This is the stacker crane which will stack the entire components. This is a mini load ASRS. This figure indicates a mini load ASRS. The load storing is somewhat less. And deep lane ASRS, you can see that for storing large quantities of stock, the deep lane ASRS systems are used. In one storage bay, more than one component can be stored. The items are stored in multi-deep storage with up to 10 items in a single rack. One load behind the next load, and the kind of retrieval is the last part that is kept in this will be the first part in retrieving this. So LIFO principle is used to retrieve the parts. Last in and first out. First in is last out. Deep lane ASRS system, a typical deep lane ASRS system you can see in this slide, in which you can see is a very big warehouse where lot of SR machines and pickup and deposition stations are available, and different kinds of parts, different types of parts, different kinds of storage capacities, everything can be structurally fabricated and kept in this deep lane ASRS systems, which is the main function of such kind of organization is in a warehouse. It will store and retrieve the parts. Man on board ASRS. This system allows storage of items in less than unit load quantities. Human operator resides on the carriage of the SR machine to pick up individual items from the bin or dryer. So a human being is kept on, he will be standing on the SR machine, and he himself will pick up the parts or place the parts from the SR machine into the bins or from the bins to the SR machine for the unloading. The operator can select the items and place them in module. Very widely, it is some kind of semi-automatic kind of environment exists with this, and in many situations this kind of man on board ASRS being used widely. Automated item retrieval system. This system is designed for retrieval of individual items or small product cartoons. The items are stored in lanes rather than bins or dryers. When an item is retrieved from the front by use of a rear mounted pusher bar, it is delivered to the pickup station by pushing it from its lane and dropping into a conveyor. Let us now discuss the important aspect of design of automatic storage and retrieval system. One is load size determination. So we have to calculate the size of the storage space and the dimensions of that. Let's say L is equal to length, W is width, and H is height. L is given by Ny multiplied by L plus X, and width is U multiplied by B plus Y, and height is Nz multiplied by H plus Z. Length, width, height, Ny, Nz, and R respectively number of load compartments in Y and Z directions, and U is the storage depth in number of unit loads. Capacity per aisle would be 2 multiplied by Ny multiplied by Nz. It's a direct simple formula, and because the either side of the SR machine can be used for storage and the retrieval system, that's why the capacity per aisle would be 2 multiplied by Ny multiplied by Nz. 4 aisles ASRS is to contain 60 storages. Compartment size in length and 12 compartments vertically. Then X is equal to 42 inches, Y is 48 inches. The height of the unit load Z is equal to 36 inches. Then the storage capacity is equal to 2 into 60 into 12. So that is 1440 unit loads. The width, length and height of the ASRS is W is equal to 3 multiplied by 42 plus 6, 144 inches is 12 feet per aisle, and overall width is 4 into 12 is equal to 48 feet, and L is equal to total length is equal to 60 multiplied by 48 plus 8, 280 feet. H is equal to 12 multiplied by 36 plus 10, which is equal to 46 feet. That's how we can easily find out length, height and width of the ASRS. Design of an ASRS still is estimating storage spaces number. Aggregate inventory level of all the product is taken into account for the determination of storage space. Total inventory of the components that are estimated on the shop floor or off the shop floor, we have to take into consideration to estimate the total storage capacity. Suppose WIP is equal to 200, and if we have the work in process is 200 and finished goods is, let us say it is another 200, then we need to take into the maximum. These are the maximum inventories. If you know that, we need to design the storage capacity of 400. If we know the size of each part, you can easily calculate the volume of the part and volume of the storage bin, and thus we can calculate number of locations, number of things in X and Y directions, etc. Estimation of ASRS, throughput and number of SR machines. The system throughput is defined as hourly rate of SR transactions that an automated storage system can perform. Design of an ASRS system. Factors that influence the system throughput is velocity of the ASR machine, velocity of SR machine, single and dual commands cycles, system utilization per hour, arrangement of stored items, speed of ASRS control system, speed and efficiency of the material handling equipment. Design of an ASRS. Estimating the size parameters of storage and retrieval system. Number of rows in the system is equal to 2 into number of SR machines in the system. You can now get it as number of bays is equal to number of storage spaces required divided by number of rows per SR machine multiplied by number of SR machines multiplied by storage spaces per system height, and number of storage spaces per system height is equal to system height desired divided by storage space height. And design of an ASRS, still continuing, and how to estimate the bay width, system width, rack length, system length, bay depth, aisle unit. Bay depth is equal to length of storage space plus center to center rack support system or rack support width is L plus X plus L1, X1. Rack length is equal to bay width multiplied by number of bays. System length is equal to rack length plus clearance for SR machine plus pickup and deposition area, where X1 is the center to center rack support width. Bay depth is equal to width of the individual storage space plus bay side support allowance, which is equal to U multiplied by B plus Z plus X2, where X2 is the bay side support allowance. Aisle unit is equal to aisle width plus 2 multiplied by bay depth. System width is equal to aisle unit multiplied by desired number of aisles. ASRS can act on two command cycles. One is called as single command cycle, the other one is called as dual command cycle. The single command cycle, in which the ASRS either perform only loading operation or unloading operation. That means the cycle starts, movement of the SR machine to a particular place and pick up the parts from that and retrieve that parts and then place it to the PD station. This is only single command. Or it pick the part from the PND station and place it in a desired location and comes back. So either it does only one operation, either pickup or deposition. This is called as a single command cycle. The other cycle is dual command cycle, in which both pickup and retrieval operations are done simultaneously. That means if SR machine will take one part from the PD station and take to the desired location, put the part, and then it goes to the location where it has to retrieve the part, another part, and retrieve the part and brings back to the PD station and deposit the part. So both these operations, loading and operations, unloading operations, are being done with same command signal. This is called as dual command signal. SR throughput, methods of SR cycle time to estimate. Throughput performance, resume, randomized storage of loads, storage compartments are of equal size, the PND station is located at the base and end of the aisle, a constant horizontal and vertical speed SR machine. We have to have a constant horizontal and vertical speed for SR machine. Simultaneous horizontal and vertical travels. So it can move like this. Both it won't move only in horizontal then vertical. Sometimes while moving it in horizontal, vertical also it will move, because these two motions are independent motions. In this, time taken to reach the desired location is very easy, very short. The single command cycle, it takes like this. The ASRS throughput, the single command cycle time is TS is equal to 2 into maximum of L by 2 plus L by 2 or H by 2 divided by Vy or Vz. L divided by 2 Vy or H divided by 2 Vz plus 2 TPD, or it is equal to maximum of L by Vy or H by Vz plus 2 PD. TCS is cycle time for single command cycle. L is length of the ASR, H is height, Vy is velocity along the length, Vz is velocity in vertical direction, TPD is pickup deposition time. The relative numbers RCS TCS plus RCD TCD is equal to 60U. RCS is equal to number of single command cycles performed per hour, and RCD is single command number of dual command cycles performed per hour. U is system utilization during the hour. The total SR cycle time, cycle rate, cycle number of cycles per hour is equal to RC is equal to RCS plus RCD. the total number of transactions performed per hour is equal to RT is equal to RCS plus 2 into RCD. Let us discuss the entire thing with a small example. The length of the ASRS unit is 280 feet and height is 46 feet. The SR machine is horizontal speed is Vy is 200 ft by ft per minute, and vertical speed is Vz is equal to 75 ft feet per minute. The pickup and deposition operations time is 20 seconds approximately to accomplish the pickup and deposition operations. So let us now calculate what is this TCS, cycle for time in single command mode. Is maximum of 280 divided by 200 or 46 by 75 plus 2 into 20 by 60. So maximum of 280 by 200 is around 14, 1.4, and this 46 by 7. So 1.4 is more. So 2.06 minutes is minutes per cycle is the TCS, and TCD is also in the same way. We can as well have 1.5 multiplied by 280 by 200 or 1.5x multiplied by 46 by 75 plus 4 into 20 by 60, and which is equal to, you have to take only maximum of these two quantities, and if you take that, it is computed as 3.432 minutes per cycle. And throughput per ISL U is 90%, single command is equal to dual command. RCS TCS plus RCD TCD is equal to 60U formula. You have to use it here. RCS multiplied by 2.066 plus RCD multiplied by 3.432, 60 into 90% you take. So RCS is equal to RCD, and 5.498 RCS is equal to 54 and RCS is equal to RCD is equal to 9.822 cycles per hour. And we can calculate as RT, and RT is calculated is 116 transactions per hour from this example. Control, how to control entire operations. We can control the entire operations of ASRS using computer. Computer has software for the entire the position of the bay and locations and the location distance from PD points, everything. And we need to command signals are also being drawn in computer program, and we need to only give the commands for deposition and retrieval commands. Principal problem is positioning of SR machine within the acceptable tolerance. It has storage compartment in the rack structure to deposit unit. It is this problem can be avoided by having the feedback sensing systems. And positioning method is counting procedures. The number of bays and levels are counted in the direction of travel to determine the position. And numerical identification procedure. Each compartment is provided with a reflective target with binary coded location identification on its face. Optical scanners are used to read the target and position the shuttle for deposition or retrieval of the load. Scanners read RFID radio frequency identification tags on pallets. The RFID targets have information like compartment binary code, position, sections, etc. Each time a storage transaction is completed, the transaction must be recorded into the computer. The computer controls the storage transactions can be entered in real time. Inventory records can be accurately maintained. System performance can be monitored. Communications can be facilitated with other factory computer systems. The benefits of automated storage and retrieval systems include highly space efficiency, increased storage capacity to meet long-term plan, improved inventory management and control, quick response time to locate storage and retrieval items, reduced storage of inventory items due to real time, reduced labor costs, and improved stock rotation. Improved security and reduced preference, flexibility in design to accommodate a wide variety of loads, flexibility in interfacing with other systems, reduced scrap and rework, reduced operations expenses for light, power, heat, etc., helps implementation of just-in-time concepts. You can see this is FedEx. FedEx is a worldwide known postal and courier services. The courier services collect the packages from all over the world and store it and transport it. The main is it is airlifted, the goods are airlifted from any corner to any corner. Temporarily storage can be done in an ASRS system. This is a typical FedEx ASRS. FedEx, they bring a lot of parcels and packages and sort them with some standards such as delivery zone, and then they load some parcels and packages into delivery trucks and delivery articles at hours. ASRS is in use, can be used many kinds of manufacturing line and distributor centers. Using ASRS with proper design will produce mentioned many kinds of benefits, and ASRS is an integral part of computer integrated manufacturing. And on a computer integrated manufacturing, the main benefit is to maintain optimal inventory levels. In order to maintain optimal inventory levels, we need to have control over the inventory and WIP, and ASRS is a ultimate solution to do that. And ASRS is omnipresent in any computer integrated manufacturing systems, and we strongly recommend the application of ASRS in a sim factory. Dear students, I would like to emphasize the application of automated storage and retrieval systems in the computer integrated manufacturing environment. And not only in CAM environment, it can be used in many operations like warehouse maintenances and other things. ASRS is used, and the kind of knowledge that we got in this lecture is that how the ASRS, what kinds of ASRS are used, how to design the ASRS system in detail, and how to control the ASRS, and the methods of controlling the ASRS, and the benefits of ASRS, implementation of ASRS, particularly in a sim environment we have discussed. So with this, I thank you very much for your patient listening, and queries you can post it to me. Thank you very much.